Hello everyone, I'm Mrs. Sudhima Vashistha and today we are meeting for our social science class. In today we'll be continuing with our geography chapter, that is the hydrosphere. Let's get started with the chapter. All right. So this is chapter 7 of hydrosphere. We have already started with the chapter where in the previous class we have talked about what is hydrological cycle, why there is uneven distribution of water or why there is scarcity of water. We have also tried to look into what are the different movements of water. We have in our previous class we have understood waves. In today's class, the topics that we will be looking into is tides. What are the different types of tides? What is the importance of tides? What are ocean currents? What are the types of ocean currents? And what are the effects of ocean currents? And in today's class, your learning objective will be you will be able to differentiate between low tides and high tides, spring tide and neap tides. You will also be able to understand what is the importance of tides. You will be able to identify the different types of ocean currents, what are the two types of ocean currents and how do they occur. You will also be able to identify the different types of ocean currents that we have in Pacific Ocean, Atlantic Ocean, and the Indian Ocean. And also, lastly, you will be able to understand the effects of ocean currents. Now, coming to tides, I hope you have heard this word before also. In a lower class, you have already learned a little bit about it. Now, let's do it in details. What are tides? Tides are nothing but they are the periodic rise and fall of the water due to the gravitational force exerted by the sun and the moon on the earth. All right, because of the gravitational force that is exerted over the earth by both the moon and the sun, because of that the water or the ocean water, there is periodic rise and fall. All right, now that is known as tides. All right, now the moon, when it comes closer to the earth, it exerts a very strong gravitational pull. All right, however the height of the tide varies with relative position of both the moon and the sun. All right, in respect to the earth. Now what will be the how high a tide will be, how that will be determined, that is determined by the position of both the moon and the sun with respect to this earth, like where the moon is located, or what is the position of the sun, like through which direction, in which directions the earth is facing the sun. So all these are the different factors which determines the height of the, or the relative, yeah, the height of the tide. All right, now when the water has reached its highest level, all right, covering much of the shore, all right, when it's like too high and it has, like, gone to a very longer extent of the shore or the beach, then those are known as high tides. All right, when the height is when the water rises up to a very high level. Now, similarly, in the same way, if the water recedes back, all right, if the water recedes or falls to the lowest level, that is known as low tide. And this high level and low level, how does it happen? Because of the only because of the gravitational pull of both the sun and the moon. Now, there's another term called tidal range. What is tidal range? Now, these tides or the fall and rise of the water, of the ocean water, every day it will happen twice. All right, twice in a day, alternate rise and fall happens. All right. Now, the difference in height between the high and the low tide. What is the difference of the height? All right, between the high tide and the low tide, that is known as the tidal range. All right, that is the difference between the height of the high tide and the low tide. Okay, now there is another two types of tides occur. One is spring tide, another one is neap tide. Now, what is spring tide? Now, apart from this regular high tides and low tides, this occurs only every day, twice a day, in a day. But apart from that, sometimes spring tides occur and sometimes neap tides occur. Now, what is spring tides? Spring tides means on a new moon day or on a full moon day, the sun, moon, and the earth, they are on a straight line. All right. Now, when the earth, moon, and the sun, they are on a straight line, that means there is a combined gravitational pull of both moon and the sun. That means now the gravitational pull is stronger. Okay, now during this time the high tides are exceptionally high and the low tides are exceptionally low. Now that is known as spring tides. Always remember, in spring, for spring tides to occur, the sun, moon and the earth, they have to be on a straight line, and because there is, combined gravitational pull of both the earth, moon and the sun, the tides are exceptionally high, and the high tides are exceptionally high, and the low tides are exceptionally low, and those are, and such tides are known as spring tides. Coming to nip tides, what are nip tides? During the first quarter and the third quarters of the moon, we all know that the moon also has its own positions, right? Like first quarter, then new moon, third quarter, full moon, right? So during on the first and the third quarter means when you can see only the half of the moon, when you do not see the entire moon. During the first and the third quarter of the moon, the sun, moon are at a right angle. All right, now when the position is in such a way that it forms a right angle, then the sun and the moons, they tend to pull the earth from both sides. All right, now supposedly if someone is trying to pull you from your head, also someone is trying to pull you from your hand also, like from which direction your balance will be distributed, right? Somebody is pulling you from the head, somebody is pulling you from your hand. So similar things happens with the earth also. Now if the moon will be pulling from the top, and the sun will be will be exerting gravitational pull from the side. So in that way this produces, so in when in such position of the moon, and of the moon, sun and the earth, the tides are moderate, they are not so high also, not too low also. Those are known as nip tides. All right, meaning that the high tides are little lower. That means normally how much the high tides should be, in compared to that, during nip tides the height of the high tides are a bit lower, and low tides are little higher. All right, the low tides are not so lower, rather than little higher than the normal average. Okay, so this was all about high tide, low tide, spring tide and nip tide. If you can see the image here, you will understand here. Spring tide, as I said, the earth, moon and the sun, they are in a straight line, and so there is combined gravitational pull. All right, so this is when the position is this, spring tides occur. Come to nip tide. Nip tide is, and you see the moon during the first quarter and the third quarter, or the last quarter, the moon is here and the sun is here, so the earth is being pulled. During the first quarter it will be pulled from above, gravitational pull, and the sun will be pulling from this side. So during this position of the earth, sun and the moon, what happens, the high tides and the low tides are a bit moderate. Okay, now let's come to the importance. What is the importance of tides? First of all, the during high tides, it helps the ships to locate their place. All right, because with the movement up and down of the water, of when the high tides occur, it will help the ships to navigate their location, or to reach their destination much more easily. Secondly, the fish, because of high tides, when the tides occur, it also carries the fish. All right, so the fish will come easily towards the shore, so the fisherman can easily collect the fishes. Thirdly, tides are also helpful in generating electricity. All right, so the turbine bells will be, sorry, blades will be there. So when the high tides occur, when the high tides will fall from a very you know big height, so the blades, the turbines, so we know how is electricity generated, right? So the on the dams are there, the turbine blades are there, on those turbine blades are waterfalls, and generator is connected, and through that electricity is generated. So for in case of tides also, when the uh, tides occur, the blades will generate electricity. All right, so an example is given here. This facility, largest facility, is a Sihwa Lake tidal power station in South Korea. This is very important, please remember. Next importance is it helps in mixing of nutrients, and it helps in sustaining other marine life. So what happens when tides occur, it will carry along with it lot of nutrients, right? Like phytoplanktons and all, like the other it will carry food for the other big fishes. All right, so tides is also important for sustaining the rich marine life, as it carries lot of nutrients along with it. The phytoplanktons and all, it will be carried in the along with the tides, and in that way it will be easier for the other big fishes for their sustenance. And then lastly, due to high tides in the ocean water, we know that it's saline in nature. Due to high tides, the salt will get collected in the low lying area. Supposedly, if the tide is coming from a high elevated area to a low elevated, like to a low lying area, then when the tide will go back, it will leave behind the salt. All right, so the salt will get accumulated, so it will be easier for, for the production of salt or for the accumulation of salt. All right, so these were the importance of tides. Now let's come to ocean current. What is ocean current? Ocean current is like unlike waves and tides which we can see, but ocean currents we cannot see. All right, this is something which happens within the water, within the oceans. All right, so the continuous movement of, now what is ocean current? When the water, or the continuous movement of ocean water in a particular direction, in a definite direction, the water keeps on moving. Now basically this movement is in circular motion. All right, so that is known as ocean current. So we have three major oceans, like so these ocean currents are majorly seen in the Pacific Ocean, Atlantic Ocean, and the Indian Ocean. And this, what is the motion? As I said, the ocean currents particularly moves in a circular motion. Now there are two types of ocean currents. One is cold ocean current, one is warm ocean current. Now what is warm ocean current? When the ocean currents are flowing from the equatorial region towards the polar region. Equatorial, we know that it's a solar insolation is more there and temperature is more there in the equatorial region. So when the ocean current is flowing from equatorial to the polar region, that is known as warm currents. And when the ocean current is flowing from the polar regions, it's colder, where ice caps and glaciers are there. From the polar regions to the equatorial region, that is known as cold current. All right, now ocean currents develop due to different factors. All right, now the ocean currents generally flow in the direction of the prevailing winds. As I said, the wind plays a very important role in the direction of the movement of the ocean water. All right, so for the ocean currents also, in which direction the currents will be moving, wind plays a very important role here. And also apart from that, uh, the ocean currents generally flow in the direction of the prevailing wind. Therefore, uh, the water from the equatorial region flows towards the polar region, and water from the polar, as we have already mentioned, from the equatorial region, water will always flow in the polar region, and from the polar region it will flow towards the equator. Now due to the Coriolis effect, now in a previous chapter we have understood what is Coriolis effect. Coriolis effect means in the northern hemisphere and in the southern hemisphere, because the earth is rotating and revolving at the same time, the wind gets deflected. All right, the wind will get deflected in a different direction. All right, so because of the Coriolis effect, the ocean currents moves in a clockwise direction. Always remember, in the northern hemisphere the ocean current will move in a clockwise. On the other hand, in the southern hemisphere it will move in a anti-clockwise direction. All right, so ocean currents are usually very deep, narrow, and they travel swiftly at a speed of 3 to 10 kilometer per hour, and the speed is 3 to 10 kilometer per hour. Okay, now these are the major ocean currents which we have in both Pacific Ocean, Atlantic Ocean, and Indian Ocean. You can also refer to your book. These are the different ocean currents. Like in Pacific Ocean, we have warm ocean currents and cold ocean currents also. In and that is also again divided into northern hemisphere and southern hemisphere. In Atlantic Ocean also, as you can see, North Equatorial, Gulf Stream, North Atlantic Drift, all these are warm ocean current in the northern hemisphere. In the southern hemisphere, Canary current, Labrador current, Greenland current, all these are in the cold ocean currents. Similarly, in southern hemisphere also we have warm current and cold current in the Atlantic Ocean. In Indian Ocean also we have cold ocean current and warm ocean current. Now let's come to the effects of ocean current. What are the effects of ocean current? First is, ocean currents influences the temperature over the globe. All right, now if in a particular area there is warm ocean current, that means the temperature will also be warmer. For example, the warm equatorial currents tends to increase the temperature. All right, if in a particular area warm ocean current is flowing, that means the temperature is also warm there. Secondly, The wind blowing over warm currents picks up moisture and causes rainfall. As we know, if the water is warm, it will evaporation will be more, right? So if evaporation is happening, condensation, then precipitation. So in those areas where there is warm ocean current, the rainfall will also be more in those areas. Alright, on the other hand, where in those places where there is cold ocean current, the air will be dry, there will be less of moisture content, so the rainfall also will be less. Like example is given here, the North Atlantic drift. Now where is the North Atlantic drift? You can see here North Atlantic drift is in Atlantic Ocean, which is a warm ocean current. Okay, so North Atlantic drift, it causes rainfall along the western coast of Europe. On the other hand, the Benguela cold current. Where is Benguela cold current? Let's see. Benguela cold current is in Atlantic Ocean. Again, that's a cold ocean current. Now, that's because the current is cold, it will not cause any rainfall. That is why there is Kalahari Desert. Alright, in Africa, in the western coast, there is Kalahari Desert. Third effect. Now, the places where this cold and warm ocean current meets, all right, in those places it creates lot of fog, you understand, right? Where lot of fogginess, like in the morning if you wake up you can see that that blurry kind of thing, right? So in those places where both cold and warm ocean currents meet, there dense fogs occur and those areas becomes more prone to accidents. Right now, if you're traveling, if there is lot of fog, you cannot see the road, what is in front of you. So for example, Newfoundland is one. Newfoundland, where the Gulf Stream and the Labrador Current, both of them meets, that is in Newfoundland, and that is much of a accident prone zone, all right, because of the dense fog which it creates. Fourthly, areas where cold and warm ocean currents are excellent. Now, they are where warm and cold ocean currents meet. They're excellent ground for fishes. All right. Now they can, like when we take bath in, sometimes with hot water we also mix cold water. Why? That is very comfortable to take bath, right? Similarly, for the fishes also, the water which has cold and warm current is comfortable for them. All right. So you feel, so those places where fishes and cold and warm ocean currents meet, it also becomes areas for excellent fishing ground. For example, Japan. All right, Japan has a rich fishing ground. All right. And lastly, again, ocean currents also helps in navigation for the ships. All right, for the sailors, the ships flowing with the current. Like if the current is flowing in a particular direction with the help of the wind, the ships can also, it becomes easier for them to travel faster, and it saves time. Like it will, on a small time only, it will make them reach to a longer distance, and it will help them to reach their destination in shorter time. All right. And also, moreover, warm ocean currents, it helps, it also might, one effect is that it might melt the icebergs, or all right, or the glaciers. So these were the effects of ocean currents. So in today's class, we have understood what is tides, low tide, high tide, spring tide, neap tide. We have understood the importance of tides. We have also understood what are ocean currents, types of ocean currents. We have looked into the different ocean currents in Pacific Ocean, Atlantic Ocean, and Indian Ocean. And lastly, we have understood the effects of ocean currents. All right, students, so that with that, we have come to the end of this chapter, Hydrosphere. I hope you have understood it. We shall meet in the next class with another new chapter. Thank you.